Question 1. Under the assumption that Maria, a database analyst, needs to retrieve employee names and their total sales from two related tables, employees and sales, but wants to include employees even if they have no sales recorded, which join type should Maria use to ensure all employees appear regardless of sales data? They inner join, B left outer join, C right outer join, D cross join. Answer. Correct answer, B explanation. A left outer join returns all rows from the left table employees and matching rows from the right table sales. If there are no matches, null values fill the sales columns, thus ensuring employees without sales appear. An inner join would exclude employees with no sales. Right outer join would include all sales but possibly exclude some employees. And a cross join produces a Cartesian product combining with every sale, which is inefficient and incorrect for this purpose. Question 2. In the context of Oracle SQL, Mr. Patel wants to replace null salary values in his query output with the average salary of the department. Which function or expression should he use to achieve this dynamically during query execution? A. NVL salary VG salary. B. Coalesced salary VG salary. C. NVL salary select VG salary from employees where department ID equals E. Department ID. D. Nullif salary 0. Answer. Correct answer, D explanation. This is tricky. NVL and coalesce cannot directly use an aggregate like AVG in the same select list without subqueries or analytic functions. Nullif returns null if the first argument equals the second, which does not replace null but helps identify unwanted values. However, the correct way to replace null with a departmental average is through correlated subqueries or analytic functions combined with NVL or coalesce, but option D is the function correctly designed for null comparison, though it does not replace null itself. This question tests understanding of when and how each function works. The correct approach would be a subquery with NVL or coalesce, but none of these options is fully valid except that nullif is used to distinguish values. Question 3. Given the circumstances that John is filtering a product list for sales between January 1 and March 31, 2023, which operator would most efficiently handle inclusive date range filtering? A. Between etwo 023 01 01 and etwo 023 03 31. B. In etwo 023 01 01, etwo 023 03 31. C. Equals etwo 023 01 01 and equals etwo 023 03 31. D. Like etwo 023 01% or like etwo 023 02% or like etwo 023 03%. Answer. Correct answer, C explanation. Between operator is inclusive and often correct for date ranges, but due to time components in date data type, between might miss records if the time is after midnight. Using explicit equals and equals with dates properly accounts for the full range and avoids boundary errors. In is for discrete values, not ranges, like is inefficient and only good for strings. Hence, the explicit range operators are for accurate filtering of date ranges. Question 4. Through the lens of data integrity, Susan is tasked with ensuring no duplicate email addresses are entered in the customer table. Which constraint should she apply to enforce this rule at the database level? A. Primary key on email column. B. Unique constraint on email column. C. Check constraint to prevent duplicates. D. Foreign key referencing another table. Answer. Correct answer, C explanation. While unique constraints enforce uniqueness, check constraints cannot enforce uniqueness across rows. They restrict individual row values but cannot reference other rows. Primary key enforces uniqueness and not null, but typically on an identifier. Foreign key enforces referential integrity, not uniqueness. The best way to prevent duplicate emails is unique constraint. This question tests the understanding, constraints, purpose, and limitations. Question 5. A demonstrated by the query client when analyzing a complex SQL query with multiple joins and subqueries, which method can best help minimize execution time while retrieving only necessary columns? They select star from all tables. B. Using explicit column names instead of star. C. Using views instead of base tables. D. Adding distinct to the query. Answer. Correct answer, C explanation. Using explicit columns, option B, is important, but views can encapsulate complex logic and pre-filter data, potentially improving readability and performance with materialized views. Select star retrieves unnecessary data, increasing EO cost. Distinct eliminates duplicates, but may add overhead. Views, especially materialized ones, can optimize execution by pre-aggregating or indexing data. They often minimize query time in complex scenarios. Question 6. From a practical standpoint, if a table has a column storing dates as varchar data type, which approach is best to ensure date arithmetic works correctly on that column? A. Use toDate to convert the varchar to date inside the query. B. Store dates as strings and rely on implicit conversion. C. Use tochar on the date values before comparison. D. Avoid date arithmetic on string columns altogether. Answer. Correct answer. A. Explanation. Dates stored as strings need to be explicitly converted using toDate before performing arithmetic to avoid errors or unpredictable results. Implicit conversions are risky and can cause errors. Tochar converts dates to strings, not useful for arithmetic. Avoiding arithmetic on strings is limiting. Conversion is best practice to enable proper date functions. Question 7. Several experts suggest that during query optimization, which of the following indexing strategies most effectively enhances search performance for a query filtering on multiple columns? A. Single column indexes on each filter column separately. B. Composite multi-column index on all filter columns. C. No indexes to avoid overhead. D. Bitmap indexes only on numeric columns. Answer. Correct answer. B. Explanation. Composite indexes cover multiple columns in a single index structure, enabling efficient filtering on combined conditions. Single column indexes are less efficient when multiple columns are involved. Bitmap indexes are efficient for low cardinality columns, not necessarily numeric ones. Avoiding indexes degrades query speed. Therefore, composite indexes offer the best overall performance for multi-column filters. Question 8. In what ways can the having clause differ in its function compared to the where clause when applied in aggregate queries? A. Having filters rows before grouping where filters groups after aggregation. B. Having filters groups after aggregation where filters rows before grouping. C. Having and where clauses perform identical filtering operations. D. Having is used for non-aggregate functions where is used for aggregate functions. Answer. Correct answer. C. Explanation. The having clause filters groups created by group by after aggregation, whereas where filters individual rows before aggregation, they do not perform identical filtering. Their purposes differ based on query phase. Having can include aggregate functions where cannot. This question tests understanding of query processing order and the role of filtering clauses. Question 9. Considering the evidence when using the merge statement to synchronize two tables, what is a critical aspect to ensure data consistency during insert or update operations? A. Using a where clause only in the update portion. B. Having a unique key or matching condition in the on clause. C. Avoiding the use of insert in merge to prevent duplicates. D. Performing delete operations within merge. Answer. Correct answer. D. Explanation. Merge allows conditional insert, update, and delete in one statement, but the critical aspect is the on-clause matching condition with unique keys to correctly align rows, while delete is optional, including it can maintain data consistency by removing unmatched rows. Avoiding insert negates merge's purpose, where clauses refine conditions but are less critical than proper matching. The question tests comprehension of components. Question 10. When considering performance, what is the main disadvantage of using functions on indexed columns in where clauses, such as applying upper on a column with an index? A. The function improves index usage automatically. B. It prevents the use of the index, causing full table scans. C. It reduces the number of rows scanned but slows sorting. D. It causes errors if the column has null values. Answer. Correct answer. A. Explanation. Applying functions on indexed columns typically disables index usage because the function transforms the column values, making the index ineffective, leading to full table scans and performance degradation. Some Oracle indexes, function-based indexes, can mitigate this, but by default, functions in where clauses usually prevent index use. The question assesses deep knowledge of indexing and function-based queries. Question 11. Given the circumstances, the Anakin needs to retrieve customer orders but wants to exclude all rows where the order date is unknown, null. Which SQL condition should she apply to correctly filter out those records? A. Where order date equals null. B. Where order date is not null. C. Where order date null. D. Where order date is null. Answer. Correct answer. B. Explanation. To filter out rows where a column is null, the correct condition is not null. Comparisons like equals null or null always evaluate to false because null represents unknown values in SQL. Using is null filters rows where the value is null, opposite of what is required here. Understanding how nulls behave in SQL is critical for proper filtering. Question 12. Under the assumption that Carlos wants to sort a report of employee names alphabetically, but with those having null last names appearing last, which order by clause achieves this behavior? A. Order by last name ask nulls last. B. Order by last name desk nulls first. C. Order by last name ask nulls first. D. Order by last name desk nulls last. Answer. Correct answer. C. Explanation. By default, in ascending order, nulls appear first. To have nulls last should be specified since Carlos wants names alphabetically ascending but nulls last. The correct syntax is order by last name ask nulls last. This clause explicitly controls null positioning in sorting. Options mixing desk or nulls first will not satisfy the scenario. Question 13. In the context of a query joining employees and departments tables, what kind of join should Lee use if she needs all employees but only those departments that currently have employees assigned? A. Full outer join. B. Inner join. C. Left outer join. D. Right outer join. Answer. Correct answer. C. Explanation. A left outer join includes all rows from the left table employees and matching rows from the right table departments. Departments with no employees will be excluded because they have no match which fits the requirement. Inner join would exclude employees without departments. Full outer join includes all rows from both. Right outer join includes all departments. Question 14. Considering the evidence when executing a query with multiple or conditions in the where clause, what is the most efficient way to improve performance and avoid full table scans? A. Convert all conditions into multiple and conditions. B. Use union of individual select statements each with one condition. C. Add indexes on all columns involved in or conditions. D. Avoid filtering and retrieve all rows. Answer. Correct answer. B. Explanation. Oracle's optimizer sometimes performs poorly with multiple or conditions because indexes on individual columns may not be used efficiently. Splitting the query into multiple selects with single where conditions combined with union allows Oracle to leverage indexes better and avoid full scans. Adding indexes helps but might not solve or inefficiencies alone. Question 15. When analyzing a query with aggregation, Maria notices that her group by clause includes non-aggregated columns that are expressions rather than simple columns. What is her best practice in such cases? A. Avoid expressions in group by, use column aliases instead. B. Use exact expressions in group by clause matching select list expressions. C. Group by only the original columns ignoring expressions. D. Use having clause to filter expressions after grouping. Answer. Correct answer. D. Explanation. Expressions in group by must exactly match the select list expressions. Oracle throws errors. However, complex filtering on aggregates is better done with having clause after groups form. Using aliases is not allowed in group by. Ignoring expressions causes logic errors. Understanding proper placement of filters and grouping expressions is key here. Question 16. From the perspective of SQL functions, why is the coalesce function often preferred over NVL in Oracle? A. Coalesce only accepts 2 arguments, NVL accepts many. B. Coalesce is ANSI standard and can accept multiple arguments, returning the first non-null. C. NVL performs better than coalesce always. D. Coalesce converts data types implicitly, NVL does not. Answer. Correct answer. A. Explanation. Dates stored as strings need to be explicitly converted using to date before performing arithmetic to avoid errors or unpredictable results. Implicit conversions are risky and can cause errors. To char converts dates to strings, not useful for arithmetic. Avoiding arithmetic on strings is limiting. Conversion is best practice to enable proper date functions. Question 17. In what ways can implicit data type conversion lead to unexpected results in Oracle SQL queries? A. Implicit conversions never occur in Oracle. B. Oracle silently converts data types, which can cause performance issues or errors when comparing incompatible types. C. Implicit conversion always improves query performance. D. Implicit conversion converts all numeric values to strings automatically. Answer. Correct answer, C. Explanation. Oracle performs implicit conversions to match data types during comparisons or assignments. However, these conversions can cause performance degradation because indexes may not be used and in some cases cause errors if conversion fails. Assuming implicit conversion always helps is incorrect, and understanding and controlling conversions explicitly is better for query reliability and performance. Question 18. Taking into account Oracle's handling of nulls in arithmetic expressions, what result will the expression salary plus null yield? A. The salary value unchanged. B. Null. C. 0. D. An error. Answer. Correct answer. D. Explanation. In Oracle, any arithmetic operation involving null results in null, not an error or unchanged value. Thus, salary plus null returns null. This behavior means null propagates through calculations and queries must handle nulls explicitly to avoid unintended null results. This question checks understanding of null handling in expressions. Question 19. During a query involving a self-join on the employees table to find employee-manager pairs, which aliasing practice ensures clarity and correctness in SQL syntax? A. Use the same alias for both instances of the table. B. Use different aliases for each instance of the table in the from clause. C. Avoid aliasing. Fully qualify all columns. D. Use table synonyms instead of aliases. Answer. Correct answer. B. Explanation. In self-joins, the same table appears twice in from clause and must have distinct aliases to differentiate instances, enabling correct column references and avoiding ambiguity. Using the same alias causes syntax errors. Fully qualifying helps but is insufficient without aliases. Synonyms are unrelated to this purpose. Question 20. When considering the use of the like operator for pattern matching in Oracle SQL, which wildcard character matches exactly one single character? A. %B. C. *D. Answer. Correct answer. B. Explanation. The underscore wildcard matches exactly one single character in Oracle's like patterns, whereas % matches 0 or more characters. The asterisk star and question mark are wildcards in other systems, but not in Oracle SQL. Knowing the correct wildcard is essential for precise pattern matching. Question 21. During the process of writing a query, Ahmed needs to display customer names along with a concatenated string showing their city and country separated by a comma. Which function or operator should he use to achieve this in Oracle SQL? A. Concat. B. Concatenation operator. C. Condoer. D. Join. Answer. Correct answer. D. Explanation. Oracle SQL does not have a built-in join or condos function. It uses the concatenation operator or the concat function, which only accepts two arguments to combine strings. However, condolis concatenate with separator is not native to Oracle and join is not a valid SQL function. The concatenation operator is the most flexible way to join multiple strings. Understanding the available string functions and operators is key to constructing dynamic text outputs. Question 22. With respect to restricting rows based on multiple conditions, Layla wants to retrieve employees who work in Department 10 or have a salary greater than 5000. Which where clause will correctly filter the records? A. Where Department ID equals 10 and salary 5000. B. Where Department ID equals 10 or salary 5000. C. Where Department ID in 10, salary 5000. D. where department ID equals tens or salary 5000. Answer. Correct answer. C. Explanation. An operator is used to compare a column against a list of values, not against a condition like salary 5000. The correct logical operator combining two conditions is or for employees in department 10 or with salary over 5000. The XOR operator is not supported in Oracle SQL. The correct clause should be where department ID equals 10 or salary 000. This question tests knowledge of logical operators and syntax rules. Question 23. Based on the information that Nikhil wants to find all employees whose last name starts with MC and ends with Y, which pattern matching condition should he use? A. Where last name like SE%, B. Where last name like MCY, C. Where last name like %, D. Where last name like MC%. Answer. Correct answer. A. Explanation. The pattern MC% matches strings starting with MC and ending with Y with any number of characters between. The underscore matches exactly one character, so MCY only matches names like Sui. %, matches MC anywhere in the string, not necessarily at the start. Understanding the correct use of % is crucial in pattern matching. Question 24. Taking into account data integrity when defining a foreign key constraint on the orders table referencing the customers table, what happens if a referenced customer record is deleted and the foreign key is defined with on-delete cascade? A. Deletion of customer will fail if orders exist. B. All orders for that customer will be deleted automatically. C. Foreign key constraint will be disabled temporarily. D. Orders will be updated to null for that customer. Answer. Correct answer. D. Explanation. With on-delete cascade, deleting a parent row customer causes Oracle to automatically delete matching child rows orders. However, the option states orders updated to null, which is actually on delete set null. Deletion failure occurs when no cascade is defined and foreign key exists. Understanding cascading actions in constraints is key for maintaining referential integrity. Question 25. In the context of subqueries, which statement best describes a correlated subquery's behavior compared to non-correlated subquery? A. Correlated subquery executes once and returns single value. B. Correlated subquery executes once per row of the outer query. C. Correlated subquery cannot use columns from outer query. D. Correlated subquery always returns multiple rows. Answer. Correct answer. A. Explanation. A correlated subquery executes once for each row processed by the outer query, referencing columns from the outer query, which can lead to performance overhead. Non-correlated subqueries execute once independently. The option stating execution once returning single value describes a non-correlated single row subquery, making the question tricky, but the essence is that correlated subqueries run repeat, not what. Question 26. When faced with optimizing a query that performs full table scans due to use of functions on indexed columns, what is the recommended solution to allow index usage? A. Remove all indexes from the table. B. Create a function-based index on the expression used in the query. C. Rewrite the query to avoid filtering on that column. D. Use hints to force index scan. Answer. Correct answer. C. Explanation. Applying functions on indexed columns disables normal index usage because the function transforms data. Creating function-based indexes on the exact expression allows the index to be used effectively. Simply removing indexes or avoiding filtering is not practical. Hints may help but don't fix fundamental issues. Recognizing when to create function-based indexes is essential for performance tuning. Question 27. According to recent studies, which a group function should be used to calculate the average of a numeric column excluding null values? A. VG. B. Count. C. Sum. D. Max. Answer. Correct answer. A. Explanation. A VG function calculates the average of a numeric column and automatically excludes null values from the calculation. Count counts rows, sums values, but does not calculate averages, and max returns the maximum value. Understanding group functions and their behavior with nulls is fundamental. Question 20. In light of recent developments, Prayer wants to execute multiple DML statements as a single logical unit so that changes can be committed or rolled back together, which Oracle feature supports this requirement. A. Sequence. B. Transaction. C. SavePoint. D. View. Answer. Correct answer. A. Explanation. Transactions group DML statements into atomic units where all succeed or fail together. Sequences generate unique numbers. SavePoints allow partial rollback within a transaction, and views are virtual tables. Recognizing transactional control is vital for data consistency. Question 29. When analyzing data retrieval from multiple related tables, what is a primary advantage of using inner join compared to a Cartesian product? A. Inner join returns all possible combinations of rows. B. Inner join returns only matching rows between tables based on join condition. C. Inner join always returns null values for non-matching rows. D. Inner join combines rows without any condition. Answer. Correct answer. B. Explanation. Inner join combines rows from tables where the join condition is met, filtering out non-matching rows, unlike Cartesian products which produce every combination, often causing performance issues and meaningless results. Understanding joins' effects on result sets is foundational in SQL. Question 30. In terms of conditional expressions, what is a major difference between case and decode functions in Oracle SQL? A. Case is Oracle proprietary. Decode is ANSI standard. B. Decode supports logical operators. A case does not. C. Case is more flexible, supports complex conditions and data types. A decode is simpler and limited. D. Decode allows nested expressions. A case does not. Answer. Correct answer. B. Explanation. Decode is Oracle-specific and limited to quality comparisons. It cannot handle complex logical conditions. Case is ANSI standard, more powerful, supporting a variety of conditions, logical operators, and data types. Neither function supports nesting perfectly, but case is preferred for complex conditional logic. Recognizing differences improves query readability and portability.